Hi everyone, welcome to this video. So today I want to solve this interesting question. So the question says find the integral of 3x divided by x squared plus 2 in brackets to the power 4 dx. So feel free to pause the video, try the question on your own, then look into my suggestions. Okay, so let's start. So we are given this integral that looks complicated, but it's very easy. So what are we supposed to do here? Okay, so what I'm going to use here is integration by substitution. Okay, so I'm going to integrate this by substitution. So what do I mean? Okay, so you can see that what we have inside here is x squared plus 2 to the power 4, right? So this is what I want to do. I want to let's say u represent what is inside there. So I'm going to have u equal to x squared plus 2. Okay, now what it means here is that I can now remove the x squared plus 2, then I can put u there. I can have something like u then to the power 4. But take note, what we have is still a dx there. So we need to have new information now about something that will relate to u. In other words, we need to remove the dx there and make sure that we change it with du. So we should see a du there, because what we are now having is u. So what do we do? So let's come back to this one here. So we said u is equal to x squared plus 2. So let me just find du dx here, meaning I differentiate this function with respect to x. So I'm going to have du dx. So du dx will give me this is a constant, so this will be 0, then we drop this here. So it will be 2, then x, then we reduce the power by 1. So what I'm going to have is 2x. Okay, so what it means here is that, remember this is the same as over 1. So I can find du. So du is equal to, so you can cross multiply here. So it will be 2x times dx. So 2x dx. Now what I want is dx. I want to remove the dx there. So let me find the replacement for dx. So I divide throughout by 2x. So you can see that you can have 2x there, 2x there. Okay, so it means that dx is equal to du divided by 2x. Yeah, so now what does this mean? So let's go back now to our integral here. Let's go back to this integral. Remember, we're finding the integral of 3x. Let me write this looks ugly. Okay, so finding the integral of 3x divided by, so here instead of saying x squared plus 2, remember we said x squared plus 2 is the same as u, so I can just say u then to the power 4. Then here instead of saying dx, I now have a replacement for dx, which is right here. Okay, so we know that dx, where there's dx, we can actually just put du divided by 2x. So here I can multiply now by du divided by 2x. Now you can see that the x here, so this x here and that x here will cancel. So it means that we now have everything in terms of u. So it makes sense now. Okay, so what we're going to have now is the integral of 3, because the x is no longer there, then divided by 2 multiplied by u to the power 4, 2u to the power 4, then du. Okay, then we can now take this. You know this rule. If you are integrating something, let's say you are integrating 3x dx. Okay, you can actually just take 3 to the front there, and it will be 3 multiplied by the integral of x dx. So exactly what I'm going to do here. So I can take 3 over 2 to the front, and I'll remain with 1 divided by u to the power 4, then du, like that. Okay, so this is now very easy to integrate in this form, because we can just use the power rule of integration. So first of all, let's write it in the standard form. Let me just write 1 over u to the power 4 is the same as u to the power negative 4, then du. Then let's apply the power rule. So this will be 3 over 2, okay, then multiplied by, so how do you integrate this one? You increase the power by 1, then you divide by the same u power. So it will be u to the power negative 4 plus 1, then divided by negative 4 plus 1, okay, but don't forget to add c there. Okay, so what are we going to have now? This will be 3 over 2. Okay, so to be u, negative 4 plus 1 is negative 3 divided by negative 3, like that, plus 3. Okay, yeah, so you can see that actually this 3 and that 3 can cancel, so you can cancel this and this like that, but I'm going to have a negative there. Okay, so what I'm going to have now is, so I can take the negative to the front if I want. So I'm going to have negative 1 over 2, then u to the power negative 3, okay, then plus c. Yeah, remember negative u to the power negative 3 is the same as saying 1 over u to the power 3. So I can actually just take it to the front, down there. I'm going to have 1 over 2 u to the power 3, then plus c. So this is our, oh, don't forget our negative there. So this is our integral. But remember, the actual problem was in terms of x. So it means that at the last stage here, we want to bring back the x information. So we want to still express our answer in terms of x. Okay, remember we said u is x squared plus 2. So the last stage here is just to replace u with x squared plus 2. So I'm going to have negative 1 over 2 like this, okay, then u, where there's u, we can put x squared plus 2 to the power 3, then plus c, like that. So this is our answer, and this is the final answer to this particular problem. Bye bye.